Yeah, good morning, all.
Good morning.
Yeah, we'll wait for 5 more minutes. Then we'll start today's session. So, yeah, today we'll be seeing week 11 summary. Did you guys go through the week 11 lectures?
Yes, ma'am.
Okay. I hope most of you have gone through it. So, week 11 is about wired and wireless communication. So, basically, transmitting data between one device to another device, right?
Yes.
What is TX?
Transistor
Transmitter.
or translator? Transmitter.
It's nothing but transmitter, and RX is nothing but receiver. Wired connection happens when the both devices are connected, right? So basically there will be two ways to transmit one data. One will be the reference voltage and another wire to which actual data has been sent, right? So this is the wired communication. Whereas in wireless communication, there will be an antenna and the transmission will happen through this, right?
Yes.
What are the types of wired transmission? There are two types of wired transmission. One is serial transmission and another one is parallel transmission. In serial transmission, there will be a transmitter and there is a receiver and there will be only one data that can be sent between transmitter and receiver at a time. That means the transmission will happen serially. If there is a 4-bit data 1011, so if this is LSB and this is MSB, so it is 1 1 0 1. So this is the data and it will be going one by one, right? For transmission of 1 bit, there has to be two wires. One is reference voltage and another one is the wire through which the data will be actually transmitted. So this is serial transmission. So for this, to transmit 4-bit through serially, we need only one pair of wire. Whereas in parallel transmission, there is a transmitter TX and there is a receiver RX. To transmit 4-bit data, we need 4 pair of wires, right? So this is one pair of wire. This is the second pair of wire. This is the third pair of wire. And we need one more pair. For the parallel communication to occur. If T is the time taken for 1 bit to travel from TX to RX, what is the time taken, total time taken to transmit the 4-bit data in the serial communication?
Number of bits.
Yes, if it is 4-bit, then it will be 40, right? Whereas in parallel communication, what is the time taken to transmit all 4-bit data?
1 T.
It is just T, right? Because all 4 will be simultaneously transmitted at time T. Do anyone have any doubt in this? Yeah. So these are the two types of wired transmission. One is serial and another one is parallel. Then we will go to the here itself. Then also we have to see here. So the wire transmission is happening between two wires, right? There one wire is through which the data is transmitted and another one is the reference. Here is the voltage that has to be transmitted. Here is the reference voltage, right? So two wires are required to transmit one data. Now, how do we model this wires? To model this wire will have some internal resistance, inductance, and a capacitance. So the equation becomes a second order differential equation. Ideally, the wire should act as a short, but in practical, this wire can be modeled using a resistor, inductor, and a capacitor. So because of that, when there is a square wave that is transmitted, in the receiving end, we will not exactly get a square wave. Instead, we get a slightly distorted square wave. Okay?
A ringing cycle.
What happened?
No, I just said ringing wave.
No, I'm not able to understand what you're saying.
And ma'am, why we take so many wires between the transmitter and receiver?
Uh, are you asking why there are two wires?
No. In transmit, we draw so many wires
Here,
and
right?
between. Yes, I am disconnected while we are discussing that.
Oh yeah. So I was telling, so there are two types of wire transmission. One is serial transmission and another one is parallel transmission. For serial transmission, whatever number of bits of data we are sending, there is only one pair of uh, wire. That is, to transmit one bit, I need two wires. That is a pair of wire. One to
Okay.
send my
In
voltage and
serial.
another is to send the reference voltage. Yes. So in serial, only one pair is required. Whereas in parallel, all the bit will be transmitted in parallel. So for each bit, there is one connection, a pair of
One wire.
wires.
Yes.
Now understood, right?
Yes. For each bit, we required one wire.
Yes.
Okay. In
Yeah, ma'am,
parallel.
I was just saying it's like a ringing sine wave. So it's overshooting and undershooting the
Yes.
above and below the values.
Yes, you are right. Yeah, what you said is right. So basically, when there are two wires in parallel, right? So there will be some capacitance in between, and each wire will have some internal resistance, and so it can be modeled using a resistor, inductor, and a capacitor. So which will result in a second order differential equation. Since it is a second order differential equation, we will have the ringing effects. So this also one characteristics of this wire transmission. So next we'll go to the wireless transmission. What are the two types of wireless transmission?
Amplitude modulation and frequency modulation.
Yes, one is amplitude modulation and another one is frequency modulation. So basically, if we use the sine wave is in the format AM sine omega t plus phi. In amplitude modulation, AM will change and the frequency omega will be fixed. Whereas in frequency modulation, AM will be fixed and omega will be modulated. Okay? So we'll just look into both with an example. So if I am going to transmit a signal that is 10111010, I will write LSB here. I'll start with MSB. So this is 0, 1, 0, 1, 1, 0, and 1. So this is the data I have to transmit, right? So I will have one carrier signal.
Now, what is the carrier signal?
The signal over which my actual data will be overlapped and it will be transmitted between the transmitter and the receiver. Okay.
Okay.
Yeah, that's what I'm going to explain later. So this is one signal. We call it as carrier signal. And we should choose carrier signal in such a way that here for one bit there will be a transmission time, right? So if I
Yes.
divide 1 by Tm, I will get Fm. This is the frequency of my data, and my carrier frequency should be much greater than my Fm. I will also explain what happens when my Fc is not greater than Fm. So if I overlap these two signal, what will I
Because
get?
when if you are like in wire when we are sending that message signal very fast, so we had the damped oscillation. So we amount like we are superimposing this on the fast carrier signal, then we're sending it like the
Yes.
speed. Yeah.
So my output will be like this. But wherever it is 0, my output will be 0 there, and wherever there is 1, my carrier signal will be reflected, right? So this is my amplitude modulation. Here it will be 0 to VDD. Here it will be between +1 to -1. So what will be my output be? What will be the range of my output? If my data is a voltage signal, it is between 0 to VDD, and my carrier signal is between +1 to -1. My output will also be in between +1 to -1. Okay?
Yeah,
Okay.
because we superimpose both of them.
Yeah. So this is how amplitude modulation works. Now we will see what happens when my carrier signal is
Ma'am, amplitude modulation means changing
yeah,
frequencies changing time with respect to time or what?
no.
Amplitude.
There are two datas which I have to differentiate. One is 0 and another one is 1, right?
One.
So to
Yes.
differentiate this 0 and 1, here see under 0, my amplitude is 0, whereas under
Yes.
1, my amplitude is +1. So amplitude is changing between zeros and 1. To
Okay.
represent 0, I am having an amplitude which is equal to 0, and to represent 1, I am having an amplitude which is equal to +1 in my output data. So a difference is amplitude is used to differentiate between 0 and 1. So it is called as amplitude modulation. Okay?
Okay.
Yeah. Now the same data, what if my Fc is very much less than Fm? That means if this wave is a very large, it's a wave with a very large time period, then in my output, how it will be?
There will be some loss.
Yes. So not even one sine wave is complete, right? I will not be able to reconstruct the signal. So that's why this rule is given.
Yes.
My carrier signal's frequency must be much, much greater than Fm. So is amplitude modulation clear? Shall we go to the frequency modulation?
Yes, sir.
Yes.
Also the retrailing part. Like, yeah.
So now we'll go to frequency modulation. So this is my data, okay? That is 10101101. So in frequency modulation, whatever ones I have, I will be using it by in my modulator signal. One will be represented by a signal with a frequency f1, and zeros will be represented by a signal with a frequency f2. Okay. So if I say F1 is around 110 hertz and F2 is equal to some 20 hertz. So for one, so this is a signal with frequency F1 and this is a signal with frequency F2. This is F1, this is F2, this is F1, this is F2, this is F1. So basically 1 is represented using a frequency F1 and 0 is represented using a signal F2. See here the amplitude is fixed. But different frequencies is used to differentiate between zeros and ones. So that's why it is called as amplitude modulation. Is it clear?
Frequency modulation.
Yeah, so it is called frequency modulation technique. Is it clear?
Yes. Frequency change according to that bits ones and zeros.
Yes.
Okay.
In amplitude modulation, see the frequency is fixed.
Yes.
Only the amplitude changes, whether it is 0 or plus 1.
Yes.
Yeah. Now, suppose there is a user 1 and there is a user 2. And user 1 has to transmit the data to user 3 and user 2 has to transmit the data between user 4. But what happens now? The data from user 1 will also be received by this user 4 and the data is transmitted by user 2 will also be transmitted to user 3. That is
Cross connect.
Number why?
yes. If M1 of t,
because it's air.
so basically the user 1 how he's transmitting, he's taking his data overlapping with the frequency carrier frequency, then he's transmitting, right?
Yes.
So A1 of t sine 2 pi fc1 t. This is the carrier info with the signal. Whereas M2 of t. So this is the
We
data.
have to remember this formula.
M2 of t. So he has a different amplitude A2 of t and he is using a different carrier signal 2 pi fc2t. Okay?
Then we have to remember this formula.
No, just understand what is happening here. That's fine. See, user 1, he is having a signal where his data is overlapped with the carrier frequency. His data amplitude is A1 and this carrier signal is having a sine wave with a frequency fc1, carrier signal 1. Then M2 is user 2. He is having another one data and he is using another one carrier frequency sine signal. Okay. But whatever the user 3 is receiving, no, he has this signal and a part of this signal. So y1 of t will be equal to, no, not y1 of t. The receiver of Rx3 will have m1 of t, which he actually wants, plus this beta of m2 of t. Okay. Whereas Rx4, the transmitter used by user, the receiver used by the user 4 will have m2 of t plus alpha part of m1 of t. Okay. Till now it is clear,
Yes.
right? Now,
Yes, ma'am.
so we saw till now what is happening in the transmitter region. There is a data, it is overlapped with the carrier frequency, then it is transmitted. Then in the receiver side, this signal y1 of t, that is this receiver, whatever this signal we got here, no, is taken. Then it is again, if it is Rx3, user 3, he wants only, he knows the carrier frequency. See, user 1 has some carrier frequency, no? That user 3 will also know FC1 because he wants only the data from the user 1. So it is being multiplied by the carrier frequency again. Then I am getting Z1 of t. So basically Z1 of t is equal to m1 of t plus beta m2 of t into sine 2 pi f c1 t, which is equal to a1 sine 2 pi f c1 t plus beta a2 sine 2 pi f c2 t, and it is multiplied by sine 2 pi f c1t. So multiply inside by each terms. So it will basically become a1 sine square 2 pi f c1t plus beta a2 sine 2 pi t c1t sine 2 pi f c2t. Now we will just expand all the term. This one is nothing but a1 by 2, 1 minus cos 2 into 2 pi f c1 t, okay, plus beta a2 by 2 sin A sin B will give you cos 2 pi f c1 minus f c2 t minus cos 2 pi f c1 plus f c2 t. We are just expanding these terms, okay? Then a1 by 2 minus a1 by 2 cos 2 plus beta a2 by 2 some cos term minus cos term, okay? This is my z of t. Now if I pass this into an integrator, okay, a1 by 2 is nothing but a signal like this, whereas this is a cos signal. This is also a cos subtracted by a cos signal. If it is transmitted in it is passed through an integrator, we will be getting the area under the curve, right? So what will happen to this area? Positive area,
Sorry.
it will become 0. Similarly, this will also become 0. Only my this term will remain. So my after passing it into an integrator, z of t will be a1 of t by 2. I'll be able to get back my data, but it will be divided by 2. Right?
So high frequency signals is not transmitted. Like
No, this is a way how we are going to reconstruct our signal. So basically in the transmitter side, so this is the receiver side, right? In transmitter side, a data
got it, got it.
is overlapped with the frequency. Then I'm having a data like this, right? Then this is transmitted. Then this is received.
So this week will not have much numerical questions. No?
Yeah, you can expect like
Yeah. And ma'am, what we see above, what that mean? What is the use of that in our field?
yeah, this is how data radio transmission under will happening, no wireless transmission. You just
Okay.
understand a basic concept of what this is.
Okay, ma'am. And what is here, ma'am? Like you told now, user one wants to send a data to user three, but it will go through user four also. So
Yeah,
what it happens here?
yeah, that's why. See, use what user like we'll see user three. Okay, user three is getting data. User one and user three are using the carrier signal FC1. Only they both know what is the carrier frequency that they need. That is FC1. But while the transmitter doesn't know, right? The transmitter is a device. It will just get M1 of T and a part of M2 of T also. Then this is the user 3's receiver side. He is multiplying with his carrier frequency. So once he multiplies it with the carrier frequency, then he sends it to an integrator. So what he is getting is A1 of T by 2. that is this data, right? He basically reconstructed what he wants from the data which he got from the receiver. Is it clear or is it confusing?
Okay, like he got unproper or half signals, but it will using that a1 by a1 of t by 2,
Mm.
he gets the full signal what user one wants to
Send, yes.
give. Yes.
Yeah. Till now, do anyone have any doubt?
No, man.
Yeah. So basically, user 3 knows like what frequency is received.
Yes. They both know the carrier frequency. So basically, week 11 is like a very small, like you can't expect any big questions from there, but you can expect like small MCQ questions, true or false, or 2 more questions from here. Okay. So basically, there are 2
It is
types.
just basically for understanding.
What happened?
And basically, it is just for
Yes,
understanding.
understanding, and you have to be clear with what type of communication these are. Okay.
Okay, ma'am.
Did you guys go through the practice assignment of this week?
No,
Even
no.
I did not complete the video lectures. That's why it is confusing for me.
Okay.
Yes,
Yeah.
ma'am. Need to also.
Yeah. Because see, this week has some practice questions, practice assignment questions. Like maybe we will solve some 2 to 4 questions here. First, we will solve problems related to the wired communication.
And here, ma'am, we see the FM. FM is the FM which we use in a real life, that signal like that
Mm,
frequency modulation.
that depends.
Okay.
So there are these 4 questions. They are related to wired wired communication. So problems for wired communication. Okay. Yeah. First, we'll see the third question. See what they are given is, suppose there are 4 devices. So suppose there are 4 devices. Each has a transmitter receiver pair, all connected to a dedicated wire medium. That is, there are basically 4 devices and each are having a dedicated wired medium, and each transmitter and receiver, transmitter receiver, transmitter receiver, transmitter receiver, transmitter receiver, and each is having a 4-bit data.
So
And
how we will know it is serial or parallel?
yeah, wait, you have to read the question now. So if the transmission occurs sequentially,
Means it is parallel, one by one.
no, the transmission between, okay, yeah. Yeah. So they're given no sequentially. So it is one. So one happens, then the next one starts, then the next one happens.
I'm like parallel.
Serial.
No, not parallel, serial. Sequentially means what? Basically, sequentially means, so if there are 4
One
things
by
that
one.
has to happen, first one thing will complete. Then the next one starts and complete. Then the next one start, then complete. So
So it is a serial communication.
yeah, serial communication.
Okay. It will happen sequence by sequence.
So I think 4 seconds.
4 wires required for each transmitter and receiver. Okay.
Yes. So they said all transmissions occur sequentially. They didn't mention which transmission is occurring sequentially. So what is the time taken to transmit 1 bit data? It is 1 divided by 100K, right? So to
Yes,
complete
ma'am.
from one device, it will be 4 into 1 by 100.
100, yes.
Like 4 into 10 to the power minus 5.
Yes. Then to complete all this 4 sequentially, it will be 4 into 4 into 1 by 100K.
As we are multiplying 4 into 1 upon 100K, so it means that particular itself is a parallel. Because if it is serial, so we have taken 1 upon 100K.
No, this is serial communication. Okay. Wait. Yeah, this is parallel communication. Sorry.
Yes, ma'am. That's it.
Oh, wait. Okay. I just drew the diagram wrongly.
Here are only 2 wires, no, ma'am. If it is parallel.
It is occurring sequentially, no? So only 2 wires is needed.
Okay. You draw 3 lines for show 2 wires. I think there are 3 wires. Okay.
There are 2 wires.
Okay.
So there should be not 4 into 1 upon 100K, only 1 upon 100K.
Why? This serial communication, no? We saw, right? In serial communication, the time taken to transmit. See? For serial communication, only 4T.
Okay. Okay, I thought it was T for serial.
If it is parallel communication, all the data will be transmitted at the same time. So it is T. Whereas in serial communication, the data will go one by one. So it is 4 into T.
1 by 1. Yes.
So what is the answer that you will get? And you have to see
6500.
in this type of question, what is the unit they've asked? It is in microsecond. So it will be 160 microseconds, right?
Yes.
Yeah. So these type of questions will be little confusing. So go through the questions carefully and then answer. Yeah. Try doing this fourth question. And tell me the answer.
So it is just 1 by 100, right?
Is it? What happened?
Because it takes T time.
Yeah. So what is the answer?
Ma'am, 4 by 100.
Not 4 by 100.
1 by 100.
Yes,
Just
1 by 100K. Because see, 4 device, each equipped with a transmitter receiver pair. They also want to send the 4 bit data 100 kHz. 4 independent wires, one for each. There are 4 independent wires and 4 independent wires, one for each transmitter receiver pair.
Parallel wire
Only parallel.
transfer. Yes. At a one time, it will transmit all data.
Yeah.
That's
And they didn't say anything regarding whether all the transmitting data, like between devices, what is happening, they didn't say. So we'll just take this as parallel connection. So all 4-bit data through all the 4 devices are traveling at the same time t. So t is equal to 1 by 100k. So it is 10 microseconds. 10 microseconds is the answer.
so when time is nothing but
No,
1 by
no,
100 k.
total time is asked. That's why I said 4 by. Like there are 4 devices. That's why.
Yeah, they
But it
didn't
is
see
in
whether.
parallel, so it
Yeah.
requires same time.
No.
In this question, they said sequentially. That's why we considered like once
One by one.
once device one complete, then only device two starts, like that we consider. But here they did not give any information about that. They just said parallel. So we will consider all as parallel. So it is 10 microsecond.
Ma'am, can you recall what is the formula to find the time?
See, frequency is given. Frequency
Yes.
for transmission of 1 bit they are given, that is 100 kHz. I want to find the time to transmit 1 bit data. What is that? 1 by frequency of 1 bit, right?
Okay.
Then, if it is a serial communication, there will be only 2 wires and
So
data
it
will be
will
transmitted like this.
do it sequentially, one by one.
If it is 4 bit, it will be 4 into T1 bit.
Yes.
Whereas in parallel communication, all will be transmitted together. So T1 bit is the time taken.
Yes. Okay.
Yeah. Now find the answer for the 5th question.
So 6 into 4 into 0.01.
Yes. So what is the final answer? It is 240, right?
Yes.
And this is a serial communication. Yeah.
Yes.
What is the answer for 6th one?
So yeah, I think it's just 0.01.
0.
Yeah, because it is in a parallel connection. So it requires the same time for all the bits at once.
One second.
So we had to find in microseconds. Yes. Okay. In milliseconds.
Yeah. I think the answer for this one question is in the practice assignment is wrong. You can double check it. Yeah, but this is a parallel communication, right? They given parallel.
Yes. But ma'am, we had to find in microseconds.
Yes.
So microsecond is 10 to the power minus 6, ma'am.
Yes. Micro is 10 to the power minus 6.
Okay.
Then later to frequency module.
How much it is given in the practice assignment, the answer?
I think the question answer that is wrong. They are given it as 80. Yeah, we'll just go to the next question. So this is a problem related to amplitude modulation. So basically we have to find F1, F2. Okay, so not this question. Yeah. And you have to find F1, F2, F3, F4 in megahertz. So basically the messenger signal is AFT and there is a carrier signal. What is the carrier frequency? What is the carrier frequency? This is the carrier signal. Omega is equal to 2 pi into 10 to the power 6.
100 kilohertz.
10 to the power 6, right?
Yeah.
Omega is 2 pi into 10 to the power 6. So Fc is equal to omega by 2 pi. So it is only 10 to the power 6. So this message signal is having two frequencies. Let me take this as FA and this as FB. So FA is nothing but 200 into 10 to the power 3. FB is nothing but 400 into 10 to the power 3. Then after modulation, FA and FB will be so once it get overlapped with the carrier signal, this frequency will get either added or subtracted. This frequency will also get either added or subtracted. So this is the four frequency signals: FC plus FA, FC minus FA, FC plus FB, FC minus FB. Then all the four values you arrange in increasing order. Then you have to find F1, F2, F3, F4.
In
Okay?
megahertz, how to convert in megahertz?
Yeah. Micro is 10 to the power minus 6, right? Mega
Yes.
is 10 to the power plus 6.
Plus 6. Okay.
So this is basically 1 megahertz. This
Yes,
is
ma'am.
400 kilohertz. This is 200.
Frequency of carrier signal is 1 megahertz.
Yes. So you apply all this in this formula, then you'll get four values. Then you arrange it in ascending order. Then you will get the values of F1, F2, F3, F4. Is it clear?
So,
Yeah, also. Yeah, there is one more formula in this week, that is C is equal to lambda mu, where C is the speed of light, lambda is
Lambda is the
the
wavelength and V is the velocity, ma'am?
no, speed is the velocity, right? Mu is the
Yes.
frequency.
Yes.
You can write it as lambda f also. No need to
Yeah.
confuse.
We will
Okay.
get the speed of light using this.
Speed of light is a constant, right? 3 into 10 to the power 8 meter per
Or
second.
8 meter. Yes.
So if you know the wavelength, we can either find the frequency, or if you know the frequency, you can find the wavelength. So this is also one important formula. Okay. Then
Okay.
about antenna. What is actually the antenna doing?
Antenna just
Yeah.
amplify the signals.
No. It is transmitting.
it's a transducer.
Yeah. This is converting some signal into an electromagnetic wave.
Yes. And transmit in the
Transmit
air.
in the air. And the same electromagnetic wave is received by another transmitter,
Received
and
by
it is
the
converted into the
another antenna. Yes.
my signal. So this is what my antenna is
Yes.
doing. Yeah. I think I have fairly covered all the topics of week 11. And tomorrow we will have the week 11 problem solving session. Okay.
Ma'am, can you just recall the formulas?
Yes, ma'am.
What the important formulas in this week in the last, so it will be helpful for us to solve the problems.
Where there is no like formula actually, like you just have to understand the concept. If it is in a serial
Okay.
transmission, what is the time? It will be nt, whereas in parallel transmission, will be only time t. If t
Yes.
is the time taken for one bit to travel from transmitter to receiver. Okay.
Yes.
So this is for wired transmission. Also, you have to know like there is some ringing effect happening in the wire transmission. Then once you come to wireless transmission, one is amplitude modulation.
And
In
frequency
amplitude
modulation.
modulation, uh, my amplitude of the like signal will vary depending on the zeros and one.
Yes.
Frequency will be fixed. Whereas in frequency modulation, the amplitude of the signal will be fixed, whereas the frequency will be varying between
Frequency varies. Yes.
yeah, that is one concept you have to understand. So you also can understand that in user 1, if he is having one carrier frequency fc1 and user 3 is having a carrier frequency fc1 and user 2 and user 4 will be having fc2. So even if there is some cross connection, like if
Cross
even if the user
connections.
3 collects the data from user 2, it's not a problem. Once you have an integrator, you will cancel out the all unwanted signals and you are able to retain the signal which you want.
Yeah. And ma'am, signal for and fourth user can also
Yeah, he will be getting a 2 by 2.
yeah, he can also find that data from user one also using that integration.
Yeah,
Okay.
for user 4, all the data from user 1 will be eliminated by the integrator.
Okay.
Yeah. Then there is this formula which is like C is equal to lambda f. Then you will also understand what is the antenna actually doing. It is just transmitting the electrical signal into an electromagnetic radiation. Right? Any doubt?
Yes.
Yeah. And I suggest you guys go through the practice assignment. Okay. There are around 24 questions here. So if you solve this, you will like get an idea of how you can expect questions from this week. Okay.
Okay, ma'am. Yes.
Yeah. Any doubts? So tomorrow we'll have week 11 problem solving. Then week 12 is like problems from all sessions, right? So directly week 12 we'll have a week 12 problem solving section. We'll not have a summary for week 12. Then after that we'll start the revision for our end term. Okay?
Okay, ma'am.
Yes, ma'am. Thanks.
Yeah. Thank you.
Thank you, ma'am.